Hello and welcome to the next part of our tour of feedback systems. So our focus in this time is going to be looking at audio feedback. And in particular, what we're going to be doing is setting up an audio manager and some helper things there to be able to work with audio in sort of a bit more of a refined way, make it a bit easier for being able to integrate audio into our game. And that's going to mean setting up some systems for some fairly common use cases. So in terms of what we've got set up wise, we have our existing project. We've set up a new scene based upon the previous one. So this we've got our pylons that are moving up and down, and we're going to rig up some sound for these. We've also got a bunch of sound effects here. So we've got a few different types of sounds that we're going to be setting up. Some things that are one-shot at a particular location, some that are going to be one-shot sounds that are just actually played without any location being factored in, and finally having some looping sounds that do have location. And to make it a little bit more interesting there, those looping sounds, we want to not just have their position change, but also have their intensity change over time. So that's what we're going to be getting set up. So in terms of with this, my audio setup, I am going to create an audio mixer. So this is going to be our main mixer. And with the setup for the main mixer, what I want to have is under my groups, I want to have a couple of children here. So one for sound effects, one for voiceover, and one for background music. Now I do recommend splitting up your sounds into different channels. We could also chuck in a UI one there as well, but having those different channels is really valuable. It means that people can then customize the audio intensity for each channel. It means you can apply different effects to them, allows you to construct and craft a much better experience sound-wise for people. So that'll be our mixer, we'll be using that. So script-wise, I want to have a couple of key things. So I want to have an audio manager. So I'm going to create an empty object that'll be my audio manager. So I'll just get a few key scripts set up first. So one of these is going to be an audio manager. Now, for audio, we've got it there as individual clips. I actually want to set up something that wraps around a collection of clips so that it's a bit easier for us being able to say, cool, play this thing, and then it can randomly pick between them. We can also have additional settings there for controlling that. So we're going to set that up where we have a sound effect. We're also going to have something that's responsible for playing the sound. So we're going to have a sound emitter. Sound emitter. So let's get a couple of key bits set up for this. So sound effect is going to be our wrapper object. So it's going to be a scriptable object. Going to also bring in using Unity Engine.audio. So this, have our create asset menu. That will just be sound effect. And the file name, sound effect as well. So we know this needs a set of clips. So that's the first thing that we're going to have here is serialize field, audio clip, clips. So we're going to be able to control and play the clip. We want to know if this is looping. So bool is looped. It'll default to false, which is good. We want to have a default volume. So volume. I'm just going to avoid using the actual name volume just by itself, just so that avoid potential collisions there with some things that exist in high def and our universal render pipelines. The other thing I'm going to put in here is being able to adjust our pitch. And that can just be like this, and I'm going to make this be a range from -1 to 1. So this will just be a flat offset on the pitch. And then we'll also be able to have it vary the pitch. Having an ability to just randomly vary the pitch each time a sound is played can be really handy for making it that it sounds a little bit different. So pitch variation. So those will both default to 0, and our default volume will be like that. So that looks pretty good. That's what our sound effect will look like. And so when we play a sound, it's going to need to be able to play it at a location, which means we need an audio source at that location. So what I'm going to do is I'm going to create a sound emitter prefab. Well, not strictly necessary because we'll be forcing its location, but handy to just set this up like that anyway. It's going to have an audio source, and that sound emitter is going to connect to that audio source. So I'm also going to change this so that sound emitter requires component, audio source, which will be good. So to save us having to actually do any searching for it, we're also going to link this up. So it can be configured in the inspector. So our sound emitter is going to be linked to that. So this is then something that we can prefab, and we'll have a few different versions of it, because this is going to be our sound emitter. We'll turn off play on awake. This one will go to SFX. But we actually have two different versions of this I want to have. One which is 2D and one which is 3D. So this one is 2D, because we can see our spatial blend setting is set to be fully 2D. So I'm going to then duplicate that. So we have 3D, and we will link that so that its spatial blend is 1. So that's cool. We'll be able to play a sound at that particular location. The emitter has the necessary script, which is good. So when we play an effect, we need to know what type of emitter to use. So this is where what I could do is serialize field, then object, template emitter, or emitter template, I think is a better term for it. That'll just allow us to control whether it's actually using that or not. Because now we can set up our sound effects. So I'm going to create a sound effect. This is going to be sound effect, pylon impact. It will grab and have the two impact sounds. So we have impact 1 and 2. The template emitter, that impact sounds, I do want those to be 3D. It's not looped. Default volume is fine. Pitch adjustment. Kind of want to deepen this sound a little bit. So I'm going to make that 0.25, but with a 10% pitch variation. Now I want to set up a sound effect for when the pylon is moving up and down. So this is going to be sound effect pylon rise, which that will bring in all of these sliding effects. Now this will again, that pylon rise is also going to be a 3D one. I will also have the same 10% pitch variation. Now rising, that's something that's going to be requiring a fair bit of effort from it. So again, I'm going to pitch that down, but then for the fall version, I'm going to actually pitch it up. So that will go to 0.25. And then the final sound effect, and actually both the pylon rise and fall, are looping ones. Those are both looping ones. And then I'm going to also then finally create one for sound effect footstep. Again, going to link this to all of these. So link up all of these ones. I won't link up an emitter at this stage, just because with these, they won't actually need to be 3D. And because they're something that's going to be very, very short-lived, I won't need to actually have them around too long. So I'm going to lower the volume of this, give it, again, some pitch variation, a little bit more this time. Maybe actually 0.15. So that looks good. So okay, I've got sound effects. I've got rough bits set up for those prefabs. Let's look at how I want to be able to use this. So if I go to my pylon, then I can set up my sound effects here. So I can set up sound effect and then impact sound, a sound effect for the rising sound, and then finally one for the falling sound. So I'll initially only get impact going, and what I'm going to do is I'm going to write the code to use the interface before I write the actual interface. I like doing this for a lot of things because I find that it means that I am implementing exactly what I need rather than potentially going off on tangents. So here's how I want to be able to work with this. I want to be able to say, okay, well, Audio Manager, play sound effect, and I want to be able to give it my impact sound effect and the location. So moving mass, position. So that is how I want to be able to work with this. So if I go then over to my Audio Manager, which we've got our object here, we'll bring our Audio Manager onto it. So I know what I want the interfaces to look like now. I'm going to get rid of these because I know that I want to be able to have a public static. For now, we'll make this void, but I want play sound effect. And then I want to be able to provide the effect and a location. So that's what I want interface-wise. But this is a static one. Our Audio Manager is likely going to have some state that it needs to maintain. So what I will also do is public Audio Manager instance get, but a private set that I'll default to null. So what I'm doing here is I'm setting this up for becoming a singleton. So that will set instance to this. But I want to make this a bit of a safety check. I want to check if that instance is not equal to null. Because if it's not equal to null, that means somehow I've got multiple audio managers present, and that's bad. We don't want that. So we're going to exit out. So the first audio manager created has priority. We're actually going to destroy the game object that this newer one is on. And we're going to log out an error. So Audio Manager already exists. Destroying the newer game object, and we'll just output the game object name. It's just going to make it easy to track down if we did have an issue. So my static functions are going to then, what they will do is that'll actually go, well, instance, and it's going to run that. So instance dot play sound effect internal effect location. So this is just a way of isolating our code and partitioning it. So we have void play sound effect internal. And that gives us our sound effect, which is cool. Need to make sure that's matching up. The only bit we've missed with making this a singleton is that needs to be static, so it can always refer to it. So now, for playing the effect, so we've got different ways we could approach this. We could have all of the logic for processing effects, kicking off playback, things like that happening within the audio manager. My general recommendation would actually be we defer this to the effect. So this actually ends up just being, well, effect, play, and we give it a location. So we put the responsibility for the playing on the actual thing that has all the data. So this can have public void play, gets a location. And then, well, this, we already have an emitter template, so it can instantiate that. So emitter game object, we instantiate our emitter template. We can say where that gets instantiated. We will put the default rotation. We're also going to set the name of it, just so that we're properly, identifying them in the hierarchy. Makes it a little bit cleaner. Then we want to get the emitter script, because we know it will have a sound emitter on. So emitter logic, we get the game object, we get the component of that sound emitter. And then we're going to tell that emitter to actually do the playback. So we'll say emitter logic dot play. Now we're going to give it the clip. So we're going to pick the clip at this stage. So var clip, go to clips, and we pick a random range 0 to clips.length. So we've picked a clip. We will tell it, play this clip. Here's whether it's looped. Here's the default volume. And we'll also give the pitch adjustment and pitch variation. So we're handing over that responsibility for interpreting this to our emitter. And again, that emitter might want to have different things, so it means it just keeps our logic a little bit cleaner. So let's enable these. Be able to have pitch variation, adjustment. That's good. We'll have our audio clip, whether it's looped or not, and the volume. So now we can actually play this, because we've already got the audio source, so we can just go, well, source, your clip is equal to clip. Source, whether you're looped, is set to is looped. The source volume is our default volume. And our source pitch is equal to, so if we take a look at what the default pitch is, and if we pick our prefabs, we'll be able to see. So the pitch by default is sitting at 1. That can go to -3 or 3. So that's the maximum ranges for it. But 1 is the default there. So we're going to say that the pitch is 1 plus pitch adjustment plus, and then we're going to do a random roll for our pitch variation. So it'd be plus pitch variation multiplied by a random range -1 to 1. So we'll set the clip, the loop, all of those things. So we're configuring the audio source. Then what we'll need to do is tell it to play. So source, play. But when it's done playing, it'd be handy to actually make it that this game object automatically cleans up. We can do that. We'll have an update. So what we will do is f source is playing, and in particular in this case actually if it is, so there might be some stuff we do there. We'll check down here if it's not playing. So if it's not playing and if it is not looped, then we're done. We've finished playing. So we know not playing and not looped. We're just going to go and say destroy game object. So we just clean up at that point. So that largely should work for our impact sounds. We should be able to just play them and that they connect through. So we can just double check we've got everything linked up for our impact sounds, which we do. Our two pylons, we are going to configure the different sounds for them. So while we're here, we might as well configure the rise and fall sounds. So we've got our rise and fall, audio manager's good to go. So we are right to test this. So we're going to run this up, and what we're expecting is the sounds will be quiet when we're further away, and as we get closer, the sounds will be louder. We're getting a little bit of the sound. And when we're right close, we hear it much louder. And we can see in the inspector our effects getting created and destroyed, which is good. So we've got the sound effects playing for impact, which is cool. What about getting it going for some of the other things though? So being able to have our looping sounds there. So, okay, this is a bit more of an interesting one because this is looping, so we need to be able to stop that sound. We also need to be able to have it be dynamic. We need it to be able to be changing during playback. So what I'm actually going to do is I'm going to make it that we can get back our sound emitter. So active sound emitter, which I'll make null. So the interface for this, I want this to be something like this, where we can go, well, audio manager, play sound effect. We know we're always rising to begin with, so rising sound. Then I want to be able to give it a way of getting the location and the intensity. So get sound location, get sound intensity. So this is what I want to be able to do for this. Which get sound location is going to be a vector3 get sound location. And that is just going to return moving mass position. Whereas get sound intensity, so I'm going to tie this to our pylons. If we take a look, they have these curves. So we sweep from 0 to 1, and this controls the progress here. So for rise, I can directly use this intensity. For falling, if I use 1 minus that intensity, because the falling one, it would make sense for it to get louder over time. So we're going to say F is rising, then return rise curve, evaluate for our current progress. Otherwise, return fall curve, evaluate current progress, but we needed to flip that, so we'll do a 1 minus. So that's good. A couple of other things we want to be doing though with this, because we need to then play the sound down here, and it might be the rising or it might be the falling sound. So F is rising, then we'd play that one. Otherwise, we'll play the falling. We need to stop the previous one, which is actually pretty easy. So F, active sound emitter, is not equal to null, which we can actually pretty much assume it won't be null. So we can do destroy active sound emitter, game object. So clean up the previous emitter. And then we start the new sound. So that's good. We can clean up the emitter. We can kick off these sounds. So that means we need different interface here. So this one is going to have a static sound emitter, play sound effect. and it's going to have the effect. It's then also going to have a function. So system func with a vector 3 for our get location function. And then it will have similar for our get intensity function. So we'll also have a system func with a float for a get intensity function. And what I'm going to do is, this one here could be used with looping sounds as well. So I'm going to update that at the same time to support passing through the sound emitter. So this will again be a instance, play sound effect, internal, effect, get location function, and a get intensity function. So very similar. We come down here. This ends up being private, but labeled as internal. So we bring this across. So that's good. This will pass those functions through because we'll do an effect dot play. Again, we can clear away these other bits. I want this one to also return a sound emitter. Sound emitter, which is very easy for it to return. It's already got a lot of that information because this, when we have our sound effect, is just going to then return emitter logic. So that's good. We've got the sound emitter version like that. We're also going to set up so we have our other function that we now need. So our public sound emitter, play, and if we take a look at the things that are getting passed through, it's just our two functions. So sound effect can receive those. And its logic here is going to be largely the same in terms of it's going to, all of this is common because it's going to do that for each of them. So this is something where it'd be handy to set up an internal thing where what I would do, something like this, a sound emitter, prepare to play. And again, we can provide a location. And that will just do essentially all of this bit of logic. So all of that we do, and it will just return that, which means we can then have a var emitter logic pair to play with location. And we also, that'll bring back the clip. So it returns the emitter logic. We can also have an audio clip, which we could make that out clip. Then out audio clip. So we're populating that as well. So, okay, we've got that. That means we can use a lot of that logic here. Now, we don't have a location. We do have a function that will give us a location. So we can just run that. So that's good. But the playback needs to know about these functions as well. So that means we're going to have here get location function and get intensity function. So our sound emitter is going to need a different version of these as well. So we'll have another public void play. Just going to paste those in there for now. Bring in this stuff as well. So the configuring of the audio source is going to be largely exactly the same. So a lot of this is pretty similar. However, that volume needs to actually factor in our intensity there. So what I'm going to do is have a float initial volume. And when we set this up, I'm going to actually be storing that. So we'll set our initial volume there like that. This, I'm just only going to set the initial volume there because what I want to do is source.volume, just so it starts at the correct volume, is our initial volume multiplied by getIntensity function. So that's good. Our source is able to be playing. Now it needs to update that intensity over time. So that means I need to store these functions. So we're going to have up here, alongside our initial volume, we're going to keep track of these. So that what I can do is run these periodically. So we'll have get location function is get location, and get intensity is our get intensity function. This will just allow it to keep track of those, because then an update, if it's playing, well, if get location function is not equal to null, then we move this object. So our position is the result of running get location function. If we have a get intensity function, then our audio source's volume is equal to our initial volume multiplied by get intensity. So now we've got something that's dynamic. It will change its intensity over time. So we can see we've got all our effects already hooked up. So we'll run this. And we can see we've got our pylon rise. We can see the volume here. So it's ramping up. That's good, we've got that. There's a bit of an offset that we can see, and that's down to the actual setup for the pylons. That's because the pylons location is a little bit offset. So that's something that we could easily, that's an issue with the setup for the pylon that we could adjust. The key thing is those sounds are changing, and if we get closer, so it's running the particular sounds, it's applying the different pitch, it's cleaning everything up, which is good. So we've got our one-shot sounds at particular locations. We've got a looping sounds. We've got the ability for sounds to be dynamic, which is really important. So the final thing we've really got that we want to hook up in terms of the sounds is our footsteps, because our footsteps are a little bit unique in that we want to play that sound, but the footsteps, if it was from an AI character, yes, we would use the existing stuff that we've got for it being dynamic, because that makes sense. But for the player, the feet are always located at a similar location relative to us, so we don't really need to have a different positional effect there. It can just be a 2D sound, and we fake it in terms of the volume, the intensity, things like that we use for it. So that means we need to be able to play a sound in a way where we're not creating a new emitter. So what I'm going to do is I'm going to set up here a SFX emitters, and this is going to have a template emitter, which is going to have an audio source on it that links over to our SFX. It's going to have that. It's not going to be looped. It's not going to play on a wake. It's fully 2D. We're also going to have that there is good. Turn that off for now. So what we want to have is a bank of emitters here that we can be using so that we can be kicking off sounds. So what I want to have is a public game object, emitter template for SFX, and I want to have a transform SFX emitter root or parent. Actually, rename this to SFX emitter template. And then we want to be able to control the number of these that we potentially have. So we'll have a serialized field here as well. Serialized field and int num SFX emitters. We might say we've got 10 available to us. So it's our pool of emitters that we can make use of. So we've got the rough setup for being able to configure our pools here of sound effect emitters. And I'm going to be able to keep track of these. So the idea is going to be that because we want to be able to play sounds not at a particular location, so we don't necessarily need to spawn something in the world, and we're going to be doing a lot of these, so churning through, doing a lot of creation and destruction there would be less than ideal. So this is something where what I'm going to do is actually make it that we've got a bank of audio sources that we can play those particular sounds on. So this is going to be SFX emitters, and that we can instantiate that list to begin with. And so what we will do is, and we'll actually do this in start. So we're going to set up the SFX emitter bank. So for int index is 0, index is less than our num SFX emitters. Then what we want to do is we want to instantiate one of these templates. So we are going to say instantiate SFX emitter template. Location, things like of that, we are going to just leave it like that. So SFX emitter game object. And what I will do is then at this point, that game object, I'm going to set its parent. So transform parent equal to our SFX emitter parent object there. So that will create it, make it a parent of that. We're going to set its name. So SFX emitter, and we'll just add in index like that. So we're giving them all a unique name, which will be good. And then our SFX emitters, we add SFX emitter game object, add component, get component for the audio source. So we'll be adding those in, which will be good. And we can also mark these as active. So we can do a set active to true at that point. So we'll have our emitter, we'll mark it as active, it will be there and ready for us being able to use. So we can take a look at the setup then for this. So we will link up our template, we will link up the parent, and then when we run, we should see a bank of emitters get created here, which we do, which is good. It's what we wanted. So a bunch of emitters that we can be making use of. So what that will mean is then for the footsteps, we'll be able to play a sound that doesn't actually have a particular bank set up or doesn't have a prefab set up. So what we're going to do is if we take a look at the character, they already have an event for being able to play our footstep audio. So what we're going to do is we're going to set up a little script, and this one is going to be called audio trigger. And the idea behind this is we'll configure a sound effect here. So serialize field, a sound effect. And then this is intended just for one-shot sounds. So what we will have is a public void on trigger. And that is going to go, well, hey, audio manager, play sound effect. And it's going to provide the effect, and it will provide through the position. So it's going to pass that through as normal. So that will work. We'll be able to connect that up, and that will play our footstep effect. So we are going to add our audio trigger onto here. Sound effect is our footstep one. And then I'm just going to connect up our footstep event to the audio triggers on trigger. So, okay, that's good. It's going to play, but that sound effect intentionally doesn't have a template connected. So I want to have a way of being able to connect that to our emitters. So what I'm going to set up is in our audio manager here, I'm going to have the audio channel, SFX. So that's going to be an enum that we have access to. That way, in our sound effect, we can also set up here the audio channel. And this is going to be channel. So what I want to be able to do is when it goes to prepare to play, so we can prepare to play, everything routes through that, which is handy. And well, this is checking for the template. It's trying to get that game object there so that it can have the appropriate audio source and the sound emitter to be playing. So in this case, these are not going to have access to a sound emitter because we don't have one of those on these. We could actually set up a sound emitter on these particular, on the template to handle that. So we could absolutely set up here that this has got a sound emitter, and we link to the source. And then what that would let us do is in our actual code, our audio one here then becomes sound emitter. So we're starting to piece this together. So our sound emitter, now the difference will be, is these will be a sound emitter that does not auto destroy. So this is going to have a bool manage lifetime, which is going to be set to true. So if it's not looped and manage lifetime, then we can use that. And so that's going to mean that these sound emitters in our prefabs, they are set to manage their lifetime. So that's good for those. These ones don't manage their lifetime, so they aren't allowed to be cleaned up, which is what we want. Now, for our ones where we're going through this, we may not necessarily want them to be able to control our functions, or we may want to be able to be resetting these functions. So the other thing that I'm going to do here is if we use this other play one, because we've got a source that we might be reusing multiple times, I'm going to just reset those to null if we end up using one that doesn't have those functions. So that's good. We've got those set up. So that looks good. In terms of what then happens in our effect here, well, we need to check, do we have our emitter template? So if emitter template is not equal to null, then we do the same logic as before. So no different to how we were doing things before. Sound emitter, emitter logic. It's null. This I will initialize here. Have our emitter logic. So if we don't have that prefab, then we need to track down our emitter. So we need to be able to go, okay, well, emitter logic. So, hey, audio manager, get emitter for channel. And we provide it our audio channel. So what this is going to do is be a function that will give us back a free channel. So public static sound emitter, get emitter for channel. So if it's sound effects, then we'll pick it from the sound effects one. So f channel equal to sfx. Then what we want to do is return get free emitter from our SFX emitters. So I'm setting this up so if we need to add in other emitter banks later, we can easily do that. So get free emitter, otherwise we return null. And again, then we have a static, this one's going to be private, sound emitter, get free emitter, get free emitter, and that has our list of sound emitters. Again, we default to returning null. What I want to do is get the first one that actually is not playing. So this is going to need, that's going to be fine for being able to access that. Now we need to access our SFX emitters, so we actually need to make this not static. So that actually has to be like that. And that's going to be instance dot. So that's good. We could actually have that still be static, seeing as we're doing the other reference. So we need the first one that doesn't actually have anything playing in it. So we're going to go for in index 0. So we're looping through this potentially a lot, so we don't want to be using for each. So in less than emitters.count plus index. And I want to be able to check, hey, emitter, and be able to query if it's not playing. If it's not playing, I want to be able to then just return it. So return emitters index. So that means our emitter needs a helper function that's just going to be public bool is playing, which we can link to our sources is playing. So now we've got that connected through. We've got our bank of emitters that we can be using. And it should pick the free one that's available and play via it. So let's test this out. Our other sounds are playing as before. I'm going to select my first emitter here because that's the one that we'll see activate first. So we're getting our sounds. They're being played. We can see that randomization of the pitch. If we take a look at our bank of emitters here, we can see it's used 0. And so it's used the first 2 to 3 ones, which for the pacing, the frequency of the sounds there, it's probably about right. We can see the volume being changed there as well. That's something where the footsteps, that volume's probably still a little loud, so I might drop that to 0.1 and run this. So got all of our sounds playing. Fi sprint. It's going to be playing a bit more frequently. What we'll also likely see if we're sprinting is that it's using a few more audio sources than before. Still not too many, still looking pretty good. We could make it that it nicely handles if we run out of audio sources, because that is absolutely a thing that could happen. So in this case, we could check that our emitter logic, so f emitter logic equal to null, and I might actually make this that the audio manager makes the decision on this. So the audio manager, if it gets to this point, then let's throw out an exception. So we're going to do throw new system, and if we take a look at the exceptions that we've got a few different ones. So here we've got, in terms of ones that are appropriate, probably we could create a custom one. I would say if we're using an existing one, probably the closest is going to be something like an out of range, or something being null, things like of that. I think one of those is probably most accurate there for it. We could also just throw a generic, system exception, which we provide the message for. So audio or SFX emitters, so sound emitters saturated, and then we don't need to return there. That way then, if we do saturate the emitters, which if I artificially lower this audio manager to say 2, so we force it getting that exception, that will mean move quickly enough. So we do actually get exceptions being triggered there, which is handy, but I will return that back up to 10. So we've got our setup. We have our ability to play a sound effect. So we set up our grouping objects here that allows us to group a bunch of audio clips. So by grouping the audio clips, that makes it a little bit more self-contained, a little bit easier for playing and working with those bits of audio there. Our audio clips also allow us to configure what sort of defaults there are for the volume, for adjusting pitch, whether it's looped or not. And we can control how it gets played. So we can either give it a template emitter, in which case it will spawn a prefab in the world and play the sound at that location. We also have the ability for it to just play on a particular channel if it's a 2D sound, which is really handy. And with our setup for this, our sound emitters, we made it so we can pass in these functions, so we can control the intensity there for it. We made it that these emitters are also able to clean up after themselves if we need, so if it's a one-shot thing we've spawned in the world. So this means that we can handle a bunch of different audio cases. So one-shot ones at a location, looping ones at a location where we're dynamically changing the volume and the location, and also 2D ones. We just need to kick off really rapid fire and we don't want to be continually instantiating things for. So we've got options there for that, all with a fairly consistent, fairly clean interface. So they all follow this fairly similar setup, which makes it a lot easier for working with them and means that from the code point of view, it's a much cleaner setup there that we've got for it. So this gives us a really good basis for setting up sound in our games, and combined with things like our bit of haptic feedback, so the rumbles that we had set up, and also being able to have that bit of screen shake, it starts to really draw all of it together. And that's the thing with feedback. It's not a case where we use just one thing. It's good to pull together lots of different elements to the feedback to layer it so that that feedback works, to a deeper level and works for more people in that regard. So it's a really good sort of way of structuring and setting it up. Thanks, folks. I hope you found the video helpful. If you have found it helpful, please do chuck in a like and subscribe. Really, really does help out. And if you're looking for the code for the project, the full code for the project is available on GitHub. I've put a link to that in the description below. If you've got any questions, chuck in a comment below. If you want to ask a question for the next Q&A video, there's a link you'll find for that in the description below as well. And if you're looking for other ways to support the channel, I do have a Patreon, and you'll find the link for that in the description below as well. Bye.